Good morning, guys. We're going to do some practice and some notes. Today, we're going to be learning how to solve quadratics using square roots. So let's start with some easy ones. You'll notice that it's the easiest time to do this when there's no b term. So remember, ax squared plus bx plus c. We're going to do this when b equals 0, so there's no center term. So we've got an a squared equals 90. Since we have a variable equal to a number, we're just going to square root both sides. Since we added the square root and the square cancel out, but since we added the square root right here, we're going to have plus and minus the square root of 90. We need to simplify this if we can. So 90, we can think of that as 9 times 10. 90 I can think of as 3 times 3. 10 I can think of as 2 times 5. Well, the 3's, we've got a group of 2. Only one can come out. And the 2 and 5 don't do anything, so the 10 stays inside. This should be mostly a review from Algebra 1. Since it's a square root, there's like an invisible 2 here. That's how many we need in a group to bring them out. So let's just do a quick review on square roots. If we had the square root of 16, we can think of that as 4 and 4. It comes out, and all we're left with is just plain 4. If we had the square root of, let's do 27, we can do 3 and 9. Those aren't the same, but I can keep factoring. Then I have 3 and 3. So these are all my factors, 3's at the ends. If I multiplied those back out, I'd get back to 27. Since it's a square root, I want a group of 2 that's exactly the same. Only one can come out to represent it. Then whatever's left has to stay on the inside. If we had, let's say I had 50, we could do 5 and 10. We could do 5 and 2. I've got 2 5's. Only one can come out to represent that group. And the 2 stuck on the inside. And that's just a quick reminder of how to do square roots. Let's finish doing some simple examples of how to solve using square roots. We're going to get rid of a square. The inverse operation is a square root. This goes away. R is equal to plus and minus the square root of 55. Now, I can factor 55 into 5 and 11, but since those are both prime, this does not reduce anymore. This is as good as your answer is. So let's make us some steps to do. Step 1, we want ax squared is equal to a number, which we're going to just call c at this point because it should be that. At this point, it's honestly going to be negative c, but we want the x term alone, the x squared term alone, and the numbers on the other side. Just the number. The next step is you're going to divide by a, and then square root both sides, Don't forget plus and minus. And then 4 is simplify square root if possible. So let's do one that's a little bit more advanced. Same concept, only difference here is I've got a 10 on this side. So we're going to subtract it from both sides so I can get that r squared term alone. I've got my r squared equals to 53. So we want x squared equal to a number. Time to square root both sides. R is equal to plus or minus the square root of 53. We want to factor this if possible. 53 is prime, so there's nothing I can do. This is literally as good as it gets. What if you don't need to add and subtract? I want that squared term by itself. I'm going to divide by 3. Off the top of my head, I don't know what 48 divided by 3 is, but I do know that 48 is 4 times 12, and I do know that 12 is 3 times 4, so I get 16. Square root both sides. B is equal to plus or minus the square root of 16. Factor if I can. So b is equal to plus or minus 4. Now, it occurs to me that plus and minus may not make sense to you. That's the same thing as positive 4 and negative 4. You're going to have two answers. When you're ready, go ahead and turn the page. This is the first time you're seeing it with negatives. You cannot do a square root that has a negative inside. So we need to first get that squared alone. Now notice when we divide by a negative, it's going to flip that to a positive. 40 divided by 5, 8. Oh, I forgot my squared. To get rid of that square, just take the square root on both sides, plus or minus the square root of 8. Now just break it down. 2 times 4, break it down again. 2 and 2. 2 is going to come out, a 2 is going to stay inside. Done. Okay, we're ready for the hardest level. This is the exact same thing, it's just one extra step. Move the other term first. Always, you're trying to get this term alone, you do addition, subtraction, you move that over first before you divide. You could divide first, but then you're going to have fractions that are ugly. The 25t squared comes down. 51 take away 2. 49. Divide by 25. This does not reduce. It is ugly, but it is fine. T squared is equal to 49 over 25. I'm purposely leaving space so that when I take the square root, there was room for me to put the square root in. Now here's a little trick. Doing this individually is annoying and hard. trying to figure out this whole fraction at the same time, doing it a piece at a time, so it's 49 over 25, that's easier. 49 I'm thinking of as 7 times 7, 25 I'm thinking of as 5 and 5. I should not have put that fraction bar there. I can't really scribble it out, but it's just going to be plus or minus 7 over 5. And that's it. Let's do another level 3. Last example. Oh. So again, my goal is that squared term alone. I'm going to subtract the 5. $41 take away 5, 36. Yeah. Divide by the 81. B squared is equal to 36 over 81. We can reduce that. I'm going to think of that as 4 times 9. I'm going to think of that as 9 times 9. Much smaller, much easier to deal with. Time to square root both sides. Plus or minus 4 over 9. Now remember, we just do each of these individually. So I'm thinking of this as 2 times 2. I'm thinking of this as 3 times 3. The 2 and the 3 can come out. And that is it. Make sure you are showing your work in your journal. Make sure you've taken your notes. Make sure that you are practicing. There will be a quiz on Friday. You guys are doing great. Be good for the sub.